Okay, in the last class we had discussed about Ohm's law, and Ohm's law is V is equal to IR. It is the relation between the potential difference and the current flowing through the conductor, and it is actually connected with a constant which we call the resistance of the conductor, that we had seen in the last class. The resistance of the conductor is a ratio between the potential difference and the current through the conductor, and this resistance has got an SI unit. It is called ohm, and this equation is called the Ohm's law. Okay, so in this class we are going to discuss about the factors that affect the resistance of the conductor. So suppose we have a conductor say this. We have a conductor and it may be having some thickness and some length, and some current is flowing through it, and we can understand intuitively that greater the resistance, lower will be the current flowing through it. And so we have to understand what are the factors that are affecting this resistance of the conductor. The first factor that affects the resistance of the conductor is the length of the conductor. So greater the length, more difficulty will be for the electrons to flow through the conductor. So we can say that the resistance is actually directly proportional to the length of the conductor. So greater the length, greater will be the resistance of the conductor. Now suppose we cut the conductor from here, okay, and if we cut the conductor from here, what we get is we get the cross section of the conductor. The cross section is like this. The cross section of the conductor means if we look at the conductor from one end, it will look something like this, okay, when we cut it. And this area, the thickness of the wire, this area, let us call it A. This area is known as the cross section of the conductor. So cross section of the conductor, right? So how is the resistance related to the cross section of the conductor? We can see that the resistance is inversely proportional to the cross section of the conductor. That means that thicker the wire, easier it is for the current to flow through the conductor. So we can say that the resistance increases as cross section decreases, or resistance decreases as cross section increases. So this is the inverse proportionality. So if we have a thinner wire, then the resistance will be greater. If we have a thicker wire, the resistance will be lesser. And if we combine these two things, let me put down the two relations first. As we have seen, the first one is R is directly proportional to the length of the conductor, and second is R is inversely proportional to the area of cross section, okay. And once we combine these two relations, what do we have? If we combine the relations, we have R proportional to L by A. And as we had seen earlier, if we want to replace this proportionality sign with an equality, then what we have to do is we have to multiply the right hand side with a constant. So if we have to convert this proportionality into an equality, we multiply the right hand side with a constant, and that constant is a Greek letter. It's called rho, RHO, rho. That is the pronunciation of this Greek letter. Let me just write down the pronunciation. It is called rho, and this rho is known as the resistivity of the conductor. So let me put down that name also over here. So it is known as the resistivity of the conductor, and it is a characteristic property of the conductor. So once again, let us see what we have over here. We have that the resistance of the conductor is directly proportional to the length of the conductor, and it is inversely proportional to the area of cross section. So we have this relation R proportional to L by A, and we are replacing the proportionality with an equality sign. For that, we are multiplying the right hand side with a constant, and that constant is rho. It's a Greek letter actually, it's rho, and this rho is called the resistivity of the conductor, and it is a characteristic property of the conductor. So from this relation which we have over here, we can write it in this manner. We can write that this rho is actually equal to R times A. Okay, it is equal to R times A divided by L. So that is what rho is, and hence this gives us the SI unit of rho. So the SI unit of rho will be, the SI unit of resistance is ohm, SI unit of area is meter squared, and SI unit of length is meter. So we have ohm meter squared by meter, so 1 meter gets cancelled from numerator and denominator, and we have the SI unit of resistivity as ohm meter. So that is something that you should remember, and it is very useful for numericals. So let us take a quick example for this. Suppose we are having some conductor having length equal to say 2 meter, okay, and the area of cross section is say 1 centimeter squared, and the resistance of the conductor, say it is R is equal to, let us take it as 100 ohm. So having got those values, let us try to calculate the resistivity of the conductor. So the resistivity of the conductor as given by this relation over here is rho is equal to RA by L. So we are substituting RA and L for the values given over here, and R is equal to 100. So 100 times A. So A will be 1 centimeter squared. If we convert it into meter squared, then it will become, you know already that 1 centimeter is equal to 10 raised to minus 2 meters. So 1 centimeter squared will be 10 raised to minus 4 meters squared, right? It will be like this, and divided by L. L is 2. So here it goes 2. So we can cancel this 100 with 2. We have 50. 50 multiplied by 10 raised to minus 4, and we can also write this as 5 into 10 raised to minus 3, and the unit will be ohm meter as we had seen earlier. So this was the discussion about resistivity of a conductor. It is a characteristic property of the material of the conductor. We'll come back very shortly to discuss about some more important points in electricity. Till then, happy watching. Thank you.